So log functions are often used to scale very large or very small numbers into numbers that are easier to understand, right? Instead of talking about like a trillion, billion, quadrillion, you might just talk about the number of zeros in that number, right? So that's what logs do. So we're going to look at three common models for logarithms: the Richter scale, which determines the magnitude of an earthquake, finding the pH of a solution, and the decibel scale, which is used to measure sound intensity. Right, so the first one we're going to look at is earthquake magnitude. Can you give an example of a number that might be used to report the magnitude of an earthquake? 7.6, something like that, right? You might hear, they kind of feel like they're between 0 and 10, right? That's not necessarily true. That's just where they tend to fall. It's not, 10 isn't the top of the scale. Right? So seismologists generally determine the Richter scale magnitude of an earthquake by examining a seismogram. So this is a seismogram of the Duvall, Washington earthquake in May 1996. So the size of these jumps is the intensity of the earthquake. Okay, so intensity and magnitude are two different measurements. And the Richter scale defines magnitude as m, which is the log of the intensity of the earthquake divided by s. And s is called the standard earthquake, the intensity of a standard earthquake, which is the smallest observable movement of the earth, right? The smallest earthquake that a seismogram can notice has intensity s. So this is just some number. So s is a number. I don't know what it is. It's some number. All right, so intensities are really big numbers, right? When we measure an intensity, it's a really big number. So to make it a more understandable number, we take a log because that makes it smaller. All right, so let's look at an example. The 1906 earthquake in San Francisco had a magnitude of 8.3 on the Richter scale. And at the same time in Japan, there was an earthquake of a magnitude of 4.9, caused very little damage. How many times more intense was the San Francisco earthquake than the Japan earthquake? So you got to be careful here because they've given us magnitudes, but they've asked us about intensities. And those are two different things. Okay? So they've given us magnitude and they're asking us to compare the intensities. So let's do a little side-by-side calculations here. So San Francisco, I'm just going to write down the formula for the magnitude of an earthquake. The magnitude is the log of the intensity of the earthquake over a standard intensity. All right, what do we know about the San Francisco earthquake? Magnitude of 8.3, and m is representing magnitude. So I put an 8.3 in here. Oops. It might help you if you imagine this is taking the log of a single number, I divided by s. All right, so now I have a log equation for San Francisco. Because there's no base written there, what base do I assume it is? 10. Okay. So if I were to change this to an equivalent exponential equation, what would it say? Ten to the 8.3. So the base is the same in a log and in the exponential. So my base is 10. My exponent is the 8.3. And that equals the intensity divided by some number, the standard intensity. And if I wanted to know just the intensity, what would I do here to get the intensity by itself? Multiply both sides by s. So s times 10 to the 8.3 is the intensity of the San Francisco earthquake. 10 to the 8.3 is a really big number, right? 10 to the 6th is a million, so it's like 100 million, something like that. Okay. So that's a really big number. Much easier for our brains to think about the number 8.3 than to think about 100 million something, right? So that's why we convert intensities to magnitudes. All right, so now I know the intensity of the San Francisco earthquake. Let's do the intensity of the Japan earthquake in a similar way, and then we will compare the two. So again, start by writing down the formula. And then what we know the magnitude of the Japan earthquake was 4.9. Switch this to an exponential equation, and we would have 10 to the what? Yeah, 10 to the 4.9 equals I over S. And then to get the S by itself, multiply both sides by S. Sorry, to get the I by itself, multiply both sides by S. So S times 10 to the 4.9 is the intensity of the Japanese earthquake. All right, so now we know the intensity of each separate earthquake. And remember, S is just some number. We don't know what it is, but it represents the intensity of the smallest possible earthquake. So let's go back to the question. How many times more intense was the San Francisco earthquake than the Japan earthquake? So if I want you to compare something by saying how many times bigger, right? So let's say, trying to think of a good example. Yeah, we look at the exponents. Yeah. So let's say, you know, I make $10,000 a year and Henry makes $30,000 a year. How many times more money does Henry make than me? 3 times, right? How did you come up with 3? 30,000 divided by 10,000. So I'm going to take the bigger number, divide by the smaller number, and that will tell me how many times more intense. Okay? So I'm going to take my intensity for San Francisco, divide by the intensity of the Japan earthquake, and that will tell me how many times more intense San Francisco earthquake was over the Japan earthquake. So San Francisco, I have S times 10 to the 8.3. And for Japan, I have S times 10 to the 4.9. I have an S on the top and an S on the bottom, so those can cancel. And then how do I do 10 to the 8.3 over 10 to the 4.9? Subtract the exponents, right? Because when you have like bases, you can subtract the exponents if you're dividing. So 8.3 minus 4.9, that would be 3.4, right? 10 to the 3.4 times as intense. And let's just get a number for that so we can make sense of it. 10 raised to the 3.4 is 2,512 times as intense. Okay, so each increase in the magnitude of on the Richter scale by 1, that actually corresponds to increasing the earthquake intensity by a factor of 10, right? So if you have a 6.0 earthquake versus a 7.0 earthquake, that's actually an intensity factor of increasing by 10 times the intensity. So to compare any 2 Richter scale numbers, you can subtract them to figure out how many times more intense. It'll be 10 to the difference. So 4.9 and 8.3 don't look very far apart, but they actually represent a really big difference in intensities. Any questions on what we did here?
So it's 4.9 places 4.8. It's a 10th.
Oh, a 10th, it would be 1 time. No, that's not right. Oh, so it would be 10 to the 0.1. So if they were different, if they differed by a 10th, it would be 10 raised to the 0.1 just 1.25 times as intense. Yeah. So yeah, you take the difference and you raise 10 to that number, and that tells you how the intensities compare. Yeah, so for earthquakes, we always use base 10, right? Because this is the formula. It's a base 10 formula. I have picked out 3 other things that we tend to use logs to measure. The first one is the pH scale, measures the concentration of hydrogen ions in a compound, right? So you just take the log of the concentration, because that concentration, which is in moles per liter, is a teeny, teeny, tiny number. And rather than writing out like 8 zeros and then 623, right, we convert it to pH, which is a number like between 0 and 10-ish, much easier to think about. So I'm going to have you answer these questions, and I will help as needed.